Nice. All right, so here we go. Number 10, ignore the drawing. So 15 kilogram block is accelerated at 2 meters a second squared. So here we go. Mass, 15 kilograms. Acceleration, 2 meters a second squared along a horizontal frictionless surface with an initial velocity of 10 meters a second and a final velocity of 30 meters a second. A, what's the average rate at which energy is transferred to the block? What are we really trying to find there? Power, right? Okay, average power, thank you. Because it says average rate, right? So I guess what I would do is just find your starting kinetic energy and your ending kinetic energy. Well, there's a bunch of ways of doing this. I guess let's go by definition. So for part A, we're trying to find average. So that's our change in energy divided by time, right? Or work divided by time, however you want to think about that. All right, so what kind of energy is our box gaining here, you guys? Kinetic energy, right? So the kinetic energy here is going to be half the mass times the velocity squared, which is what, 750 joules, I hope? Is that right? And down here, the kinetic energy is going to be 9 times as big. So what's 9 times 750? 6750, is that right? Is that right?
Yep.
All right. Any problems with what I just did there?
No.
All right, so now I know my change in energy is 6,000 joules, because that's the difference between these two guys. Hang on 1 second. There are other ways of doing this. Give me 1 second. And then you got to divide it by the time, right? So you got to use old kinematics equations. So my velocity is going up by 20 at a rate of 2 per second. How long is it going to take? 10 seconds, right? If you want an equation, it's that. Okay? So divide it by 10 seconds, and you get 600 watts. All right? So that is one of the several ways of doing it. Daniel, and then Peter?
So, is it a coincidence that you can find parts B and C and then subtract them and it's 600?
No.
I feel like
Oh, yes.
that one is, right?
You can average them, and it's 600. That's not a coincidence.
Okay.
The fact that the difference between them is 600 is coincidence.
Okay, and then you can also do it with final work minus initial work over time, right?
Final work doesn't make sense.
You can't,
So why am I saying that? What do I mean when I say final work doesn't make sense?
because it's like not. Okay.
But work by definition is a change, right?
Yeah, it is the change. Okay.
So you're talking. I guess you could say final change.
The
I
average
guess,
is-
but it's.
Yeah.
So what do you mean when you say final work and initial work?
Well, power is the change in work over time, kind of.
It's just work over time.
Just work. So you can't. Okay. So I did.
It's
200.
either work over time or change in energy over time.
Okay. Yeah. Then
Good?
it's another coincidence. Then I think.
Sorry.
I think it's another coincidence then, because
Gotcha.
yeah.
All right. You okay?
Yeah, yeah, thanks.
I would try as much as you can to stick to the equations. You know what I mean? Just Peter.
So what I did was since it gave you that acceleration is 2 meters per second squared, I just said that acceleration as a function of time is equal to 2, and then took the integral twice, and it gives you initial velocity as being 10. So then when you take the integral, it's 2t plus 10. And when you take the integral again, I just assumed that my initial position was 0. Then you get t squared plus 10t, and then you get 200 meters times the 30 newtons that you're exerting. That's 15 kilograms times, and then divided that by the 10 seconds.
Okay. I think everything you said there makes sense. So A, awesome. Like that worked, right?
Yeah.
Okay. So cool, because you're showing like sound understanding of how the concepts fit together.
Yeah.
All right. And I would remind all of you, anytime you've got constant acceleration, I don't want to see integrals, because you're making your life way harder than you need to. All right. What you really basically did there was you used that equation to find your displacement, right?
Yeah.
You could have just done 2a delta x equals vf squared minus vi squared, and that would have given your displacement. Do you know what I mean?
Yeah.
And I don't say that to be like, yay. I'm glad you did that and that it worked. And you got to be conscious of like sort of the most efficient way to get there.
Yeah.
And really, if your acceleration is constant, there's not a reason that you should be doing integrals and derivatives.
Alright,
Cool?
yeah,
But I'm still impressed, so understand?
yeah.
All right, everybody good? Okay, cool. So then to do parts B and C, to find the instantaneous rate of transfer, well, it's just force times velocity, right? So, what's the force? 30 newtons times your velocity. Cool? All right. Questions with that? All right, so that was number 10.